Okay, well, welcome everybody. Thank you for joining. I appreciate you taking your time to spend a little time with me. If you want to know more about me, I'm not going to go through everything, but yeah, you can go to my GitHub README page. It covers a lot of my experience and what we're kind of doing, an overview of Practically as well. And you can have a look at my Git statistics if you really want to. And so I am I founded Practically, so the practical.li website. It's got all the kind of books I'm writing, so quite a few. So mostly around Clojure and Clojure web services and some of the tooling. I'm also doing a more general engineering playbook as well. So like very specific kind of guides to doing very specific things that we commonly do, like signing Git commits and things like that. And as mentioned, I kind of work for Griffin. We built an immutable bank now for people who want to have financial services, but they don't want to go through like getting a banking license, which can take many, many years. And yeah, we're hiring. So if you want a job, then feel free to come look at our open positions. That's the advertisement stuff over and done with. So I guess the fundamentals of what we're going to talk about today comes down to having a really nice like workflow when you're doing Clojure. It's really nice to kind of have the REPL driving things and giving you that fast feedback while you're building stuff. And so one of the tools is like a component framework, which there are several of them. So we're going to mainly compare Donut, so Donut Party system, and Integrant REPL. So you can kind of see which of these two tools like really kind of appeals to your workflow. And I'll try and cover like a comparison and which ones, and why I kind of like one over the other and which features I like from each of those as well. But they're all kind of following this kind of reloaded workflow. So that means you can keep your REPL running. You don't have to stop and start your REPL. So you can keep a lot of the state, a lot of the setup that you have in the REPL without having to start from scratch each time. And so I do this in just a normal Clojure project. I have a whole bunch of tools that I will start from my REPL reloaded workflow. And I'll just run the REPL, connect my editor, but also have things like a portal that starts up there. So I can do some data inspection as well as I go along. And so taking that idea of being able to reload namespaces, a lot of that is done with like the Clojure tools namespace library, and you can kind of extend that to a web application server as well. Let's skip over that. So we have like the have this idea of this Clojure service REPL workflow. And so you can use lifecycle tools like Donut, Integrant, Mount, Components itself. And I basically create these like functions, helper functions, to basically start and stop the service as well without having to start and stop the REPL. And also inspect the system configuration as well. So if something's not quite working right, you can kind of see what the structure, what the components are in the system, or what their values are. Again, very easily, which is quite useful when you're debugging something. Feel free to ask questions as we go along. And I'm just going to kind of cover like the basic concepts, and then we'll dive into some code later on as well. And so hopefully you're kind of familiar with the web application. You've got a web server running in the REPL, and you have your connected editor, connected REPL session, and you might have an API with Swagger on there as well, and portal data inspector. One of the other libraries that's quite useful, although I'm not really going to show too much around this today, is aero. Which is a nice way if you've got lots of environments, you want to kind of have a lot of differences between each environment. Aero is a really nice library to help you define a profile for development, testing, staging, and production environments. And so you can set up different database connections very easily just by using aero. And so mount, for component libraries, there's mount, which is, it's a bit more than just having an atom, but and there's a little bit of magic around there as well, but it's quite a simple system. But you can also kind of not use any of these. You can actually just have your own atom and manage that yourself. So we'll see a very simple example of that first. And then we'll have a look at donut system and Integrant REPL. There's a kind of distinction between Integrant and Integrant REPL, which we'll kind of cover. So Integrant is more for the running system, and Integrant REPL you would use when you're actually developing the system. And there's a few other libraries there as well. And there was a really nice video on Integrant by James Reeves, the author there as well. So there's a link there if you want to know more about the background. Do you have any comments? No, not yet. Okie dokie. So just before we dive into the code, so I've created a few projects already in the best Blue Peter tradition. If you're from the UK, you might know what that means. If you're not, then I apologize for a vague reference. So I'm using practically project templates where I'm trying to kind of codify a lot of my workflow into that already. So a lot of the tools I run when I run REPL are already kind of built into there. And I'm using the practically service template, which creates an API, a very simple kind of API with Swagger and all the REPL tools there as well. And optionally, you can use, you can include component, so either donut or integrant, or you can just create it without any component system whatsoever. So let's have a look at some code. Oh, and yeah, so the project templates is part of the, if you've got the project practically Clojure CLI config, it's in there as well, but you can also kind of add that. I think I do have an alias somewhere that shows how to add that in there as well in the project templates. Yeah. Cool. Let's dive into the code. So we have, so I created some projects, again, just by using this project create alias, specifying the template, giving it a project name, and then either component integrant or component donut or neither. So the first one, I've just created a service here without any component library. And these projects are kind of all very similar in structure, so they're fairly easy to compare with each other. And so the entry point really is this service. So we've got this main service namespace, and we're starting so we're including HTTP kits, but you could also include Jetty in here if you prefer. We've got some other things like Mulog, which is my preferred logging framework as well. And yeah, we've got a simple function to start port, so start the HTTP server on a specific port that we pass in. And we've just got a simple main function to just set up some global context for our logging, event logging. And then we're just pulling in the port, or we're setting up the port number, either pulling that in from the command line and making sure it's an integer, or yeah, by default we're going to run that on 8080. We don't specify anything, and we got a little shutdown hook. Yeah, when we get like a Control C, we're just kind of gracefully shutting down the application server with a little timeout here. Just so it like kind of gracefully shuts down. So if it needs to close anything, it gives the Clojure code a little bit of time to shut down before the application server does. So that's like 100 milliseconds. So there's nothing to, so this kind of main namespace is just designed to be run from the command line or from on your server. If you actually want to do some development, then there's a dev section and a user namespace. And so here we're basically setting up some like REPL workflow, and I use a namespace called system REPL in here. So this pulls in like the start and stop and restart functions I want. So even though I'm not using a component framework, I'm still doing start and stop exactly here. And this is very kind of basics of mount. So I'm just using an atom to record the HTTP server instance. So when I start the HTTP kit server, it creates an instance, and you can use that instance, that reference to that server to shut it down, essentially. So I have a stop, which will get the server instance and send it a timeout. And so I can shut down the server if I wanted to. I can start the server, which again is just similar to what we had in the main. And then I can do a restart, which is very simple restart, which is just stop, refresh, start. And so the refresh. The refresh is just using very simple, very specific kind of libraries using the Clojure tools namespace REPL. There is also the CLJ reload, a library that's been recently released, which is kind of, takes a lot of these ideas and adds a little bit more like capacity to reload code. So Clojure tools namespace is great if you've got reloadable code, but there are some things that it won't kind of reload smoothly, like the def records and things like that are not so good. But if you check the CLJ CLJ-reload project, then it tells you what extra things it can do for you. But if you're writing very reloadable code, then that's the Clojure namespace REPL is more than enough. So this is just calling that from that. So basically this is if I have any namespaces that have changed, then it will reload them. So it will kind of get rid of any stale references. So if I have some defins where I've gone in and changed the name, but I haven't kind of removed that from the REPL. So if this was starting rather than start, then if I'd evaluated start, I'd still have the start function available within the REPL, even if I was using starting. It's not so much of a big issue in the main code, but when you've got tests running and you've evaluated those tests and you forget to kind of remove them from the REPL, then you're going to be running a lot of extra tests that are failing because they're no longer kind of relevant. They become stale. So this is my non-component library component library. And some of the other things I've got in here is like Portal. That's just simply running the Portal data inspector. And I've got a mulog publisher, which will just publish all the events. It basically just taps all the logs to Portal as well. So let's see, it's going to run. This might slow down my computer a little bit, so I apologize if it gets a bit too crazy for a second. But here we're running Clojure with some test environments, so adding some extra libraries for testing. It started up the Portal data inspector. Oh, look, I've already got a log message already. So that's just an example log message from my user namespace. Just confirms it's all working as well. We can start And so the user namespace is loaded by Clojure by default, and that's loading the service REPL for me. So I've already got the start and stop functions there. So I do start, and it's running a REPL. So if we go to localhost 80, oops, I can type, boom. I have an awesome API. So this is just like a Swagger UI documentation, an interactive kind of page for calling the API. So I can call the API and boom, there we go. It's I can call the status and it's just telling me, okay, yeah, the service is alive. Hey, there we go. So that's simple. And I can and here it's showing me that, yeah, it's reloading. It's showing kind of what libraries it's reload, what namespaces it's reloading, and then it's starting on server for 8880 again, and we're done. And then we can do stop. And it shuts down. And so we've still got the REPL running, but we're no longer running the application server. We can still do Clojure. 1, 2, 3, and we still have everything that we've kind of loaded already still in the REPL memory if we wanted to do that as well. But yes, so sometimes it's useful to kind of stop the server if you're kind of making a big refactor and then start it again just to make sure it's kind of loaded everything in there as well. Any questions? No questions yet. Okie dokie. So that's the kind of basics. So what I did was kind of build on this with Donut and Integrant. Oops, sorry. I'm going to show you the extra pieces now. Why? Oops, I forgot to close that down. There we go. Don't need that. Right. So I'm going to show Integrant. Integrant. I can't even say that anymore. Integrant next. And I was going to. Oh yeah, I've got those here. So this is a comparison between kind of Integrant, between the normal, the API service, and in this case it's a Donut one. And you can see there's not really much difference. Like there's a couple of different files in there, and in the difference between Integrant and Donut, again, there's not much difference there. Because I've kind of structured where I'm putting the configuration into kind of specific files. I guess the biggest difference with Integrant is it has like a resources config in there, which is a kind of convention that they use. So we'll have a look at that as well. So let's go back to our code. So the project is kind of the same. So so if we go back and look, see how it runs as a service by itself without kind of like the development workflow. So I've got another service file in here. And it's the same code. We've got a main, but this time we're kind of optionally pulling in, we're like optionally setting in a profile. So we can define a profile, whether that be dev, test, and so on. So that will allow us to kind of set up things in the config so we can have different configurations for different environments. But pretty much everything else is the same. We've still got mulog, pumping out the configuration and a global context. We're creating this local variable here to capture the running system. So this is kind of the reference to the running system. And so we're going to initialize all of the components in the system using the profile, which by default is dev, but we can have that as prod as well when we're running the application itself. And then we capture this running system, the actual the reference to the system configuration. So basically, so we can stop it. So we've got this again, this shutdown hook, which is a little bit of Java, just allow us to shut down gracefully the components, and this triggers Integrant to shut down all of these components we have in the system. Yeah, so there we go. Yeah, so this is very similar to this. Is just adding a little bit extra to call, to set up the system by Integrant. And so the system configurations in resources, and we have this configuration Eden. And I think the main reason it's in resources is because it's typically read as a file. And yeah, it's quite common to put files that you're going to read into the system within resources, because then that works within a jar and a jar. And this is, as the name suggests, it's a big Eden file. So this is one of the aspects that makes Integrant a data-driven lifecycle management, data-driven component system. Because your configuration is simply a hash map. And so a hash map has keys and it has values. And so in this configuration, we set up where the services are defined. So I've got an API service system called log publish, which will start our log publisher. So it's going to take, so this is going to capture all the events from mulog. So when you do a log event message, it's going to capture all those and publish them out to whatever kind of publisher we want it to. So it could just be on the console. In here we're doing console, we're sending out JSON. But we can also publish that to a wide range of different services as well. We can also have tools like Zipkin, which is used for tracing events, so we can kind of see how long events are taking and like dive into the events that take too long or much longer than expected. And then for prod, we're just pumping out to the console. If we're running it in Docker, then we're kind of doing Zipkin, because we can have Zipkin all set up with inside Docker, so we don't need to install it locally. And in dev, we're just putting that to console. We could just have like as console, so you could print out as Eden if you wanted to. But essentially, what Integrant is doing is allowing us to define these services as keys, and these can be any kind of namespace. So these are fully qualified namespaces, so they can be anywhere inside the project. This is a relatively simple project with so I put them all into the system namespace. For me, that keeps it nice and simple. And because these are services that are just going to run, you can find out where they all are because they're all in the same namespace. And so, we've used the aero profile here, but there's also these tag literals from Integrant itself as well. So we have a reference. So this HTTP server, this is a component, and it's got a reference, basically a dependency on a handler, and the handler is defined in this function here, and we're going to have a port and whether we want to join the server thread or not. And then the handler is also defined as a key in here as well. Yeah. So the router is there. Yeah. So the router kind of has these dependencies on persistence and data provider. And so the persistence is, as you might guess, kind of the relational store we have here. We fit them both on there. So we're defining this persistence key, which gives us a link to the key inside the integrant configuration. So this reference here to relational store, because you could have persistence that is like a very different kind of database. It's obviously Postgres is a common one. You could have persistence as like Foundation DB or any kind of other database, or MongoDB. And this relational store key is defined above. And this is just setting up the database connections. And what we will do with the routers, we're actually passing in, essentially passing in the persistence and data provider information into the router, which then makes it available to all the kind of the request handlers. So every request handler kind of knows where to access the relational store because we're passing in the database information. Any questions? Nope. And so the database relational store, again, we're using, these are all aero tag literals we're using. So the host is either going to be the environment variable database host, or if that returns, if that's empty, if that's false, essentially, then we'll use localhost. So you can set up some defaults and the preferred environment variable. If you're using environment variables a lot, then having a profile becomes less valuable because each of these environment variables on a different environment, so will point to a different database host and different database username and password. So database username on dev is probably going to be different. Hopefully it's going to be different to database username and password on production. Otherwise, you could do some very naughty things, which is not good. And the data provider is just setting up some endpoints for third-party systems. So we're just passing those in so that they're available to whatever request handlers would need them. Okie dokie. So all these services defined as keys with their value as a map. And so they're all in system. So if we go and look in system, we can see how we start them, or how Integrant is going to start them, and how it's going to shut them down. So we're including Integrant core in here. So this is the kind of main library. This is like the runtime library of using Integrant core. So it starts and stops, helps us start and stop the component. And we got HTTP kit and mulog there as normal. We got this initialize function, which is helping us just parse the config, parse the profile, and it basically updates the config with the particular profile. So whether it should be a dev profile or a production profile. And then for each of the services, we've got this init key. So this is an Integrant init key method. And so for each of these, we just basically specify the name of the component. And so this is the same as that key in the resources.config.eden file. And so we can pull from that key its hash map. So we are basically destructuring the hash map that is associated with log publish in the config.eden file. And we're pulling out the information that we need. So here we got log publish. It had this information about the publisher, so what type of publisher it is and whether to print, that sort of stuff. And so we can pull that out. I'm just, for completeness, I'm putting in a mulog statement here to just to capture what that configuration is. So this is just like a hash map of the configuration, and just recording the time that it was sent out as a log message. And then we just basically start the publisher. So we create a local reference to the publisher, which we can then use to also shut that down as well. We just start the publisher with the configuration that we want. And each of these init keys does the same thing. Some of these might just be reporting what the actual configuration is, just for clarity of when it's when the system's starting up. So for relational store, we don't really need to configure anything, except we've got the connection there. We're just like checking we've got that connection details present. If you're using environment variables, then it's useful to do that, because you might not have picked up the environment variable by the Java virtual machine. So if that's kind of blank, then you can troubleshoot the issue quite quickly. And then we've got the router. Again, the router doesn't do too much. But yeah, we're passing in the configuration into the router app. So again, we're pulling in the persistence and the data provider like endpoints into this configuration, so it knows where they are. So that saves us doing stuff in code. It saves us actually configuring and passing in like the database connection information into the actual request thing. It's just already there through Integrant. And then the HTTP server, yeah, we just again start the instance and capturing that instance in Integrant. And so that's everything kind of started. And in the config, some things relied on other things, so that will control how those components will start up and stop. And then if we do want to stop some things, then we have the halt key. So rather than the init key, we've got the halt key. And again, these one for each of the components we want to stop. And this just allows us to kind of gracefully stop these things as well. So we'll stop the HTTP server, again, just by calling the instance, which will then stop the server. We could also pass up a timeout to that as well, which I think we did do in the config, actually. Yes, so it's already there in the config. And then for the log publisher, we can do something a little bit extra just to make sure we've flushed all the events from the log. We've published them all. We just add a little sleep in here before we actually call the publisher reference, again, to shut itself down. And then we can stop the system as well. So this is called, and this will, so when the stop is called, this basically stops all the other components in order, and our job is done. Okie dokie. Hopefully I'm making lots of sense because nobody's asking any questions. So that's basically how it works when it's running. Again, there's also the dev space here where we got the user workflow. So when we're actually doing REPL driven development, we can use this. And again, we've got the system REPL. We're pulling in a few extra pieces here, putting in config and restarts. There's a few extra functions, helper functions we've got, but essentially everything is kind of the same. So let's look at that. Yeah, so here so now instead of Integrant core, we're using Integrant REPL. So this is a separate library. It's an extra dependency. So it does kind of separate them out. So you could have this just in an alias rather than in your main dependencies. And we've also got REPL state. So we'll show examples of how those work as well. We've got this environment prep, which basically will take the profile and pass it with this aero prep function. just to basically return a hash map without all the aero configuration in, with just the configuration for a specific profile, like specifically for dev or test or stage or prod. And then we've got our start and restart all. Again, these are just kind of wrappers around the Integrant REPL functions. And yeah, just basically, yeah, it's like giving you the option to pass in the profile directly into those as well. So you could actually, you could start by running dev, but then realize, oh, actually, I want to stop my environment and actually start it up in a stage or even production environment. But essentially, it's doing the same thing. And then I've got system and config, which are just helping me understand what the running state is or what the actual configuration is. So if something's not starting up correctly, and it could be an aero issue, it could be something in the config, I can see what the config is before I start the system. And then once all the system components are running, I can also go and inspect the system state as well. And that will help me understand if everything is working as expected. Cool. No questions so far. And portal and mulog are, I think they're exactly the same. I haven't changed those. Yep. So let's try and start this one up. See here. I've got a make file in here, so I just type in all the aliases. But essentially, yeah, this is just running Clojure with some test environment. So basically some extra test libraries and my REPL workflow. So it's running portal for me, and this is listening to all of the things I evaluate. So if I do and then so that's running. If I do mulog log. Yeah. There you go. So this is yeah. So all the mulog things will go into portal automatically because it's got a publisher that publishes there as well. So it's quite nice. So you can have a complete kind of REPL history inside portal, or clear it out whenever you want to, and just keep the important bits. And then, oh yes, we wanted to start something. So I included a little help menu, which looks a bit better when it's kind of full screen itself. So you can start, restart, stop. So it kind of tells you what to do. Because it always, sometimes if you're working on a new project, then how do I run things? Well, it's nice to have a little help menu to kind of show you that. So if I do config, it should show me that I don't have a config yet, and I don't have a system running yet. If I do start, this should, well, it's been a while since I used this project, so hopefully this is not where it fails. Initiated, there we go. So if I have system now, then I can inspect system. You can see the keys. So practically API service system. So we've got like the data provider here, which has got all the endpoints in. And then we've got the relational store, which has got the host and port and username. Obviously, the very secret username and passwords. And then it's got a handle on the router as well, and the HTTP server, and the log publisher. So each of these is a little function that we can call to shut those down, which Integrant manages for us. I did start, so in theory, Go to our web browser, localhost 8080, if I remember right. Ta-da! There we go. We've got an API. We can run that. Ooh, there's a cat. And my cat's wanting my attention. And we can call these. Let's go a bit slow. And we can try these out again, and they're running. Yeah, and so status. Ooh. Yeah, status is live. There we go. So we're confirming that it's working by using it. Obviously, you can kind of do this is like what you would set up for like a heartbeat, and you would listen to that as well. That's what I've done before. This is a more kind of user friendly. Normally, you would just like have a ping response as a simple thing. You can do that as well. Okie dokie. So that's working. Yeah, there's also like I've got Mulog tracing the events when we do a request, so it's also capturing the get and the post that I'm doing here as well. So it gives me a lot of information about what I'm doing there, and just pumping that into Portal, which is very nice. So if I'm calling something and it's doing weird things, I can very easily see what it's doing. I've got all the information in here. And I should be able to restart. That's doing a lot of stuff here. It's basically just stopping and starting all the services, and yeah, because it's in the user space, it's kind of firing off a few more log messages, so telling me all the services that are starting. So yeah, we've got the API service starting, and we're in dev, and there's an object reference to the time. We've got the publishing config in there as well for the Mulog publisher, and we've got the HTTP component, the log publisher, the router app. So it's all working very nicely and smoothly there as well. And stop. Close. Programmatically close the portal as well. It's got a really nice API around it, so it's very handy. And then if so I can now start and stop the server component with inside the REPL. I can do all the reloaded workflow that I want. When I'm doing a refresh, it's using, I think it's using Clojure tools namespace REPL to refresh underneath as well. Although I think it should be possible to kind of use the CLJ reload as well with these libraries. It's not something I've tried yet. And then REPL, let's quit that. Oop. Is there anything else? Oh, yeah, I didn't show the router last time. So I'm using Reatit, with like pretty standard setup. This is just the same setup in each of these projects as well. We've got Swagger and Swagger UI to generate like some nice documentation. Yeah, I think so I've got some middleware as well, which basically just listens to all the requests and does some nice kind of printing out of those as Mulog event. So we're using Mulog trace and Mulog. So set some context up, and then we just trace each event as well, which gives us more information about how things are going. And then that just passes the request on to the handler, because this is just a middleware piece. So that's pretty straightforward. And then the router, this just has all the different routes in here. configuration. So it's the app. Yeah. So the app is taking this kind of system configuration that we've already set up inside Integrant already. So it's got the persistence key. If I wanted to do some database work, I can just use a persistence key from this system config and get the database details and write things to the database. Alrighty. And then last but certainly not least is, we're not going to look at build, no. Boop. Boop. That's going slow. Close this down. There we go. Yeah, so now we've got Donut project. So again, this is very similar to what we already have. But I find Donut just that little bit easier to understand and to reason about. It's kind of has some similar principles, but rather than having a separate resources file, we don't have that. It's all within the source. And so I have the service as normal. So this is just the same thing. The only difference here, we're using Donut system, and we're going to pull in the system namespace to do that. And we still have a running system, but this time we're doing Donut start rather than Integrant. We're optionally pulling in the profile. I haven't really used aero with this this particular project, but it's very easy to do so. And then the biggest difference, so rather than having this resource config.in, we've just got a system Clojure file, which is just a bit of Clojure. And this is using Donut. And I'm defining a system. And the system is called main. This is the main system I'm going to use. So this is what I'm going to run as my main system. And this is just a hash map. Lovely, lovely hash map. So this is basically just kind of very similar to Integrant, like having a configuration as a hash map, except yeah, we're just using Donut definitions. So we have all our environments set up under the env key. And so here we're defining like an application version. So this is just a map of all the environment information we want to kind of have for the system. So we've got HTTP port, and again we could use aero here, or we're just basically pulling in an environment variable using getenv, or you could use the env library if you wanted to. And we're setting up persistence here with database hosts, port, password, etc., etc. And so we're going to use this environment information in some of our config for our services. And the services are the same. So we've got a publisher. So we can define with Donut how we're going to start that publisher. And we're going to use a function to define how that's run. So we're using an anonymous function, but we're actually giving it a name. I give it a name for convenience, just so it's like clear what it's doing. I just find that a little bit easier to read. And it's going to take some information from its configuration. And the configuration is defined under the config key. So you've got under each component, you've got the name of the component as the key, and then you've got donut start, stop, and config. So it's kind of all there rather than split across like different def methods. It's all kind of there in one single place. So again, I find it easier to kind of see what it's doing and comparing the code together as well. You could actually have separate functions for these if they were doing like quite a lot of work, but usually they're very simple. You don't need to. You can just have them inline functions. So we're taking the configuration. We've got this global context and publisher, which both have hash maps. And so we're taking those as keys out of the config, which is referred to here. And then we are just setting up the normal global context and creating a log event, and then starting in the publisher with that configuration. So again, console JSON and pretty. And then this has like, so this is returning this kind of reference to the publisher, and so we can use that instance to use this instance that we have in the stop function, and we'll just call it. And again, we're by passing in this sleep function just to make sure we're printing out all the events before we shut it down. That's all the same. And then for the HTTP server, I've separated this out a bit. So I've got a HTTP server. I guess I could also have a HTTP client and some other things as well, but I've got the server component and I've got the handler. And so the server, again, is just taking the configuration options. So we're using this local reference. So within this HTTP definition, we can have a local reference to this handler key to pull in this piece of extra config. So if you've got a lot of config, you can kind of split it across different keys and just have a local reference and pull that key in. So that's defining where our router wrap is, and again, passing in our env and persistence, so passing in our database connection information into there, so it's available to the router, which then makes it available to the handlers. And yeah, there's like kind of usual options there as well. And then stopping, yeah, we just stop that. Log it, stop it with the instance. Pretty straightforward. So rather than having two separate files with a config and def methods, you basically got everything in one place. So yeah, I do have a preference for Donut now because I just feel it's like simpler to reason about and it's just simpler to write as well. Anything else? I think that's about everything I need to show. Obviously, with Donuts, there's a lot more kind of things you could do. Oh yes, there's the user side of things. I haven't actually shown you the workflow, so that's a config. Let's show you the workflow. So again, it's in my user file, which is automatically loaded when the dev directory is included in the path. And then, yeah, the usual things. So we've got our system REPL with our start-stop system restart. And the normal, same thing here as well. There's nothing different in there. So let's have a look at the system REPL. So this is kind of the interesting thing you can do with it, because you can have multiple different configurations. You don't just have to have a single configuration. In Donut, you can set up a main. You can set up a dev environment. So this is our main from our system file that we're just pulling in. So that's the default configuration we're going to run with. But we could also have like these other named systems. So we could just run dev in there and override some of the or extends like the configuration that we have in main, and put other things there as well. So, for example, in the main, we might not want to join. Well, so in the main, we would like join the server thread, so we can kind of see the server output. We don't really need a REPL prompt when we're just running that service live. But in development, we'd want to disconnect from that so we can kind of see and interact on the command line with a REPL if we should choose from. I mean, obviously you can do that from the editor, but sometimes it's nicer to kind of like start and stop things on the command line and have a separate kind of tool to do that. So we can override any kind of environment variables just by injecting this. Yeah, it's a hash map of values that we can put on top of there as well. And then we can, yeah, I've just got the start and stop and restart systems here as well. So I can start, by default, I start the dev system, or I can pass in a name system, and that allows me to kind of have a lot more control. There's a lot more you could do with this that I haven't done that. I mean, you can set up like very specific kind of test configurations that you wanted to. So I think there's a lot more extensibility, a lot more obvious extensibility you could do here with different name systems, which I kind of struggle to figure out how to do well, or in a way I want to do that in Integrant, but I'm probably missing something there. But yeah, Donut really helps me kind of like figure out the different kind of systems I wanted to, and at work we've got a mono repo with lots and lots of different services. So we'd have lots of different name services, one for each kind of system there, because they're all kind of independent from each other, but also have lots of different ways to test them as well. There's a lot of integration testing, but sometimes we might just want to do unit testing as well. So the way we kind of configure the system will make it easier to do certain different types of workflow around a larger project as well. Alrighty, I think I'm done.